Good morning, guys. Today we are looking topic is what is VLAN, Virtual Local Area Network. Virtual Local Area Network means virtually how we are identifying the different local area networks. Also logically it is connected. Those things only we can see through this tutorial. So first we want to understand the virtual local area network word by word. So first we understand the network. Connecting the device through the wire medium is copper cable. We are using a medium copper cable for connecting the device. Then also provide the IP address for its identity. So any IP address devices we can identify in the network. It should like a door number. So for example, one street is there, it has a number of houses. So each house has a unique door number. Like that, in the network, every device has a IP address. Without IP address, we can't trace out. It is a traceability purpose only. Understand local area. Local area means all the IP addresses devices are placed in same place or within the campus, within the building, like that. Then we are connecting the devices through wire. Then we are using a centralized hub or switch for network communication purpose. So local area means these all are within the campus. So we just call it is a one group of local area, another group of local area. So virtual VLAN means identify that different local group of devices. How we are identified logically through the devices, mean network devices. So the special term is virtual. How we are identifying the virtually group of devices means local LAN. So in the same place, n number of local area networks should be available. We should identify separately each and every local group of devices. That is most important thing. So I am using few diagram here. It is a network diagram 1. It has a 5 devices, one centralized hub or switch. 8 means 8 port. 8 means 8 port. So usually we know hub or switch will forward both broadcast and multicast out every port. So this is a fundamental. So it is a single network. So all the devices will communicate through the hub. Also peer devices also. Okay, like that I took two more networks. It is network 2, same thing. Like that network 3, this is also same thing. So it is a these three networks are available in same place, but different group of devices connected with IP address. How we are managing these devices through the hub, that is a thing. How we are identify the devices logically through the network device, that is the thing we are looking here. So totally three networks with three different IP addresses. For example, network 1 IP has 192.168.1.0. So it is a class C network IP address. So slash 24 I am using 24 sub 24 means subnet mask 255.255.255.0. First three octal is a network part, last remaining octal is a host part. So network 2 I am using 2.0 slash 24, network 3 3.0 slash 24. So totally used 3 hub or switch for network communication. So our requirement is 3 hub or switch for the network. But it is not a scalable solution. Why it is not a scalable solution? We will think it in our next slide. For example, I placed all the devices in the same place. 3 hub are using. So it is allow only 3 numbers or 5 numbers devices. So that's why you can manage easily. So there is no any issues. But in the real environment, if you think it has a n number of switches within the building or corporate office, anything, it has a minimum 100 L2 switches are available. So maximum we can't count it. How how many their employees and how many their recruitment, how many were their production. According to that, it will increase. So we have to manage all those things. I'm just showing three set of network only here. So we need a scalable solution for manage it. So it's called manageable switch. We are using a manageable switch. What it will do, it will share the database to other switches. So every every switches will become a single switch because the database shared between the switches. So we can easily identify group of devices where it is, then which network, then which IP. Like that we can identify. So those things only we are looking here. Now, now we want to we want to make it something. How network will become a VLAN. So three network become a three different VLANs in the L2 layer. Network 1 will become a VLAN 1 or 11. So I defined VLAN 1 and 2 for this tutorial, but you can assign 11 or 52, 67 or some other anything else because we know the VLAN range 0 to 4095 IP IDs are available for identify the VLANs. So we assign the network for VLAN. Then in layer 2 level only we are calling virtual LAN. Okay. Now single manageable switch is enough for network communication for this tutorial. So I am explaining these things through water tank concept. It is a very easiest way and remaining and remain yourself very easily quickly. That's why I choose this model. Just to consider, it is a virtual water tank. So water tank, I have two tanks, water tank 1 and water tank 2. It has different color of water are mixed. For water tank 1 has a purple color, sky blue color, red color. Like that water tank 2, brown color, green color, yellow color. So these color of waters are mixed means the color should be different definitely. But here it is not like that. I write the statement here. It has color of water are mixed. Okay, first we follow this like this way. Then you will understand. Then also I fix the pipelines for the each water tanks. First has 7 pipes. Second has a 6 pipes. Then I define the first pipe of both water tanks should be a specific color of water should flow through the pipe. Water tank 1 has purple, water tank 2 has a brown. So the particular what color of water only will flow through that particular pipe. So this is one idea. Like that I define the second pipe also the same color. So first two pipes are flow the same color of water. So each VLAN represents a unique broadcast domain. So the the color of water will flow through this pipe only means it is a unique, it won't mix with other pipes. Okay, so how you are defining your ports in the switch, how you are defining your ports as a access port accessing this particular VLAN. How I defined it here. This pipe should be a purple color. Like that VLAN port access we can define. Now I am defining the third port sky blue color and green color. Again like that in the water tank 1 sky blue color, but in water tank 2 yellow color. So those waters only will come. We can define anything, but once we defined that particular color of water, what will flow through that pipe. Now I defining fifth port as a red color. In water tank 2, I defined the fifth pipeline as a green color. So the traffic between device within the same VLAN is switched. The same VLAN traffic will switch between the two devices. For example, here you just look at water tank 2. pipeline third and fifth both are green color. Like that, pipeline 1 and 2 both are brown color. So the VLAN traffic switched between these two only. Means wherever you define the same VLAN, those traffic only switched between within the VLAN. Now I define the sixth port in water tank 1 red color, and here it is a brown color. So broadcasts from one VLAN will not be forwarded to another VLAN. For example, every pipeline water through should not flow through the other pipes because it is already defined with some other color. So like that, VLAN broadcast only flow within the VLAN only. Same wherever you assign the same VLAN, that VLAN only forward the broadcast and unicast those things for the particular specific VLAN. The same thing I explained seventh pipe one, I defined it here. So the color of water identified by tag. So color of water is identified by the tag in the device, network device called VLAN tag. So in the water tank, it is identified by the color. So the particular color of water only flow through the pipe like that. But it is mixed within the water tank. No, it is logically identified by the tag. So water tank 2 also logically identify the tag. So VLAN tag are inserted in the layer 2 header. We know layer 2 is a data link layer. In the data link layer, the frame header will be inserted called a tag. Through the tag, we can the devices will identify the traffic belongs to which VLAN. Network or LAN are identified as a VLAN in layer 2 using tag. Tag is the most important, uh, actually it is a uh, key role of the data link layer. So LAN or become VLAN in layer 2. Now just imagine two water tanks will become a switch 1 and switch 2. Network or VLAN are not mixed, identified by the tag. VLAN provide the logical separations identified by the layer 2 header tag. So why we are referring this tag? The tag is playing the key role because three different group of devices means three different local area networks are available in the same place. We identify these three groups using the tag. All are LAN only, but define the tag for particular group of devices, it will become a group of devices through the ID. So virtually we can identify through the network communication device. So it's called manageable switch. Okay guys, so I hope you will understand this concept. Thank you.